housekeeping information, and to ensure you have you make the most out of this event. So first thing I would like to share and make sure we are all on the same page is what this event is for, what's the focus, why we do it, and then I'll jump into some housekeeping. So first, what is Abracadata? Abracadata, or why did we make this event? First is we all know that there's so many AI conference articles, websites, trainings, everything is AI. And I suppose I do feel overwhelmed by all of it, by all the information about AI that we see everywhere nowadays. And yeah, on one side, it's like, oh, I don't want to make something or create more content about AI, right? There's it feels like there's enough. But on the other side, what we on our team saw a lot, or we're seeing, is that there's just there's too much information on, like the usage part of AI, uh, but there's not enough emphasis on how that actually happens behind the scenes. What happens under the cover of the car. I mean, so what we're doing with this event is sharing that, trying to share, putting our grain of salt, to share how things happen, basically how that AI magic happens. That's why we came up with this magic theme, right? How does this magic happen? What are the activities that are done? What is the work of the data engineers and data scientists that are behind all this, right? So that's what we're trying to do with this event. I mean, establishing a program of sessions and topics around this is quite challenging because there's lots of stuff. We try to provide just some, like small pointers, small bits of information to provide insight on some of the things that happen, some of the work that the data engineers and data scientists do, how they do it, which tools they use, which practices and techniques they use, um, so that to provide you some insight and so that you can further go deep on this on your own. So basically, that's why we do this. That's the reasoning. Now, I want to make sure. I mean, this is the first event we do for this. Abracadata is actually an initiative that we're starting. This event is kicking off this initiative, but we plan to do more things. We know that just doing an event once or twice a year um, is too doesn't provide much engagement. Is too disconnected. So we plan to do more things. This is just the kickoff. Abracadata is an initiative. The other important thing that I'd like to mention on why we do this is because we want to provide some global um, insight or view into what's happening around data engineering, data science, and how they shape AI. Um, we want to provide a view of what's happening in different places of the world, right? Because most of the information we all receive is from what's happening in the US. And yes, I mean, it's very important. But also, we want to share, okay, what's happening in Latin America, what's happening in Asia, what's happening in Africa, um, what are organizations doing, uh, which kind of problems are they tackling. And another bit of content that we do include, and you will see in the program, is also the public policy side on some of the things. How it's up, because most cases in I suppose, if you like me are a lot on, like tech newsletters and all that, usually most of the use cases and everything is around the same thing, around financial, around tech, how data engineering is applied to a very narrow set of fields. And so that's why we also provide an insight on how this is used for things that impact public society. So that's why you will see some sessions regarding how this is applied to topics like homelessness or health or others. So having said that, I've took enough of your time. Just a few housekeeping announcements. All sessions are being recorded immediately. They're available. It's usually the first question we get asked. How can I watch this later? Well, if you click on schedule up at the top, if you see a button that says schedule, if you click on it, you'll get a drop down of all sessions. And once a session is over, you can simply click on watch replay and the recording is immediately available. That's one of the things we like best about this platform. Also, please engage. There's the chat, there's the feed, make questions. We will have time for addressing questions at the end of the sessions, of most sessions. There's a leaderboard going on. So um, we will be raffling some. Well, it's not raffling actually. The 5 top places will get an ebook from our friends from Pack Publishing, who provided digital books for the people who engage the most in the leaderboard. So how do you get points in the leaderboard? By asking questions, by attending sessions, by engaging with exhibitors. Basically, any activity you have in the platform provides you points pretty much. So engage, feel free to, I mean, to meet, to talk to some people from other places that are doing things similar as you. Okay, so that's pretty much it. We will be sharing more information along the day, along the event. The team that is organizing this event, we're also organizing other events coming soon. We're organizing Beam Summit in Apache Beam Summit in New York City. We're organizing um, Airflow Summit in Seattle in October. We're organizing another online conference. Open Source Analytics Conference in November. So we'll be sharing also some links to other things we're doing. We hope you are interested in them. Some of them I said online, some in person. So having said that, let's get started with our first talk. It's a pleasure to introduce our first talk. As you know, this is the first event and the kickoff event for Abracadata. It's a new initiative and community. So we had to invite friends, people whom we admire, and also that we've collaborated with in the past. And Omar is one of them. Omar Sanseviero, who is presenting this first talk. Hi, Omar. How are you?
Hey, how are
Thank
you?
you for meeting us. Omar is now well, many of you probably know him from his days at Hugging Face. Now I understand that he's with Google in DevRel. Well, you, Omar can share more what he's doing with Google now. He is joining us from Paris right now. So it's a pleasure to have you with us, Omar. Please feel free to get started.
Perfect. Thank you so much, Pedro, for the intro. So yeah, hi everyone. I'm Omar. I'm originally from Peru, although I grew up in Mexico at least for high school and college. I've been working first as a software engineer in Google Assistant. Then I joined Hugging Face at a very early stage, working in the open models ecosystem, building integrations with different open source tools, really making sure that the open models are as accessible as possible to the developer ecosystem. And since 7 months ago or so, I joined DeepMind to work in Gemma. If you don't know Gemma, it's the family of open models from Google. I'll talk a bit more about that. Uh, and today's talk will be about open models. I'll talk very briefly about use cases, fine-tuning, and the tooling and the ecosystem as a whole. Uh, it's a very complex topic with many different moving parts, so consider this as a high-level view of the state of the world right now. Yeah, let's get started. So as I was saying, Gemma is, so there are many hundreds of, even thousands of official open models by different companies, research labs, institutions. From DeepMind, we have released Gemma. Gemma is a family of open models based on the same research as Gemini. And open models means that these are model weights that you can download. You can run this in your computer, maybe. It depends on the model size, but you may be able to run these models in your computer, in your phones, in your own servers. So you have actual control and ownership of the weights in some way. Uh, it's a it's a way to really make machine learning more accessible, right? So, for example, you can run some of these Gemma models in an iPhone or in an Android phone rather than having to call a server. You can do things called you can modify the model for your own use cases. I will talk a bit more about that. What is quite exciting is to see the growth of the developer ecosystem. So we released the first Gemma model about a year ago, in March of last year. At the beginning of this year, so just 6 months ago, we had 100 million downloads, and we saw a 50% growth just in 5 months. This number is a bit outdated, so I computed some numbers earlier today. Today we have 170 million downloads, so it's very exciting to see what the community is building with Gemma. And again, this is just for the Gemma models that we have released. There's a whole ecosystem of open models that you can use. Uh, and within DeepMind, we have released a couple of different things. So we have what we call the core Gemma model. So this is similar to Gemini or to ChatGPT. These are models that will generate text based on an input. These are generalist models, so models that you can chat or models that you can fine tune or modify for your own use cases. So we released Gemma, Gemma 2 last year, Gemma 3 just a couple of months ago. And then we released Gemma 3N just 3 weeks ago, which is a model specifically for on-device, so for running the models in a phone. Apart from what we call the core Gemma models, we have also done what we call variants. So for example, we released just a few weeks ago MedGemma at the bottom, which is a Gemma model for medical use cases. Uh, in the context of open models, the medical domains are quite interesting because there are many privacy concerns that many health-related institutions want to keep the data local. They don't want to send data to any servers. So it's quite interesting to see the adoption that MedGemma has been having in just the 3 weeks it's been out. And similarly, there are other projects such as CodeGemma for code-related generation, ShieldGemma, which is more for safety applications, or SignGemma, which is to do sign language back to English. That's for the American Sign Language, and there's ongoing work with different institutions to do a SignGemma version for Indian Sign Language, for example. There are a bunch of different sign languages. And as I was saying just a few months ago, we released Gemma 3. It comes in different model sizes from 1 billion parameters all the way to 27 billion parameters. And the goal is to share some of the best open models that can run in consumer GPUs. That means that these are models that you can most likely run in your own computers at home without having to buy extremely expensive GPUs for computers. These are multimodal models. That means that you can pass text, images, short videos, and for some of the models, even audio as input. Uh, we have done lots of work in multilinguality because at the end of the day, the goal is not just to share models that work for English, but rather models that work across a large number of languages. So we have worked to make sure that Gemma works well for 140 languages, and also that it has a large context. So if you're not familiar with context, the idea is that when you pass text to a model, there is a limit of how many words or how many tokens you can pass to the model. Uh, Gemma originally had a very short context, so just 8K tokens or parts of a word. And with Gemma 3, we released a much longer context model. So you can share up to 128K tokens, which is equivalent to 400 pages of text or 500 images. So it's not huge, but for the local inference, it can be quite exciting to see what the community is building with this. And then you can kind of mix multimodality with multilinguality. So for example, here, what you can see is that you have an image that has text in different languages, and the model can have a good understanding of multilingual, multimodal situations. So in this case, an image with text in different languages. And what is very important in the open source ecosystem is really to focus on the community. So talk with the developers, understand what researchers are doing, how people are deploying these models, and really add new features. So for example, the long context was one of the main feedbacks we had for the Gemma 2 and previous models. So try to iterate quickly based on the community feedback. Uh, there's something called LMCs or LM Arena or the chat leaderboard. It's all the same. It's a leaderboard in which users, anyone, so you can go to this leaderboard yourself. You can chat, so you can type something, and you will get two responses of two different models. And these responses are anonymous, so you don't know which model generated which response. So what you can do then is pick which is the generation that you like the most. And after thousands of chats and submissions from different people, you can build some leaderboards, some ELO scores, so similar to chess, in which you can see which models are more preferred by the community. It's not a perfect leaderboard, as all of the benchmarks and evaluations in the machine learning ecosystem, all of them have some issues, but it's a very good proxy to understand what people like the most. So you can see here in blue the Gemma models. All of these are just open models, so models that have open weights. And then the dots at the bottom is the number of H100s, which is a type of GPU. You can replace this with a A100. It's the number of GPUs that you would need to just load the model. So you can see that there are some models that are better than Gemma, but again, our goal with Gemma is not to make the best models, but to make the best models that users can actually run for their own use cases. So we are quite excited about the results that we have been able to get. And as I was sharing, our goal is to make it strongly multilingual. So it's kind of, I don't know if you can see it, it's here almost at the bottom after the half. After the middle, you can see Gemma 3, the 27 billion parameter model, does kind of well for English compared to other models that are proprietary, but it has very good performance actually for French, Spanish, Japanese, and Korean. And what is even more exciting is the part of fine tuning. And now I'll switch from talking to Gemma to talk a bit more broadly about the whole open source ecosystem. So there, we have been working very closely with these developers, so people that are developing tools for developers, to make sure that when we release Gemma or other models, people can use the models very easily. So, for example, Google, of course, has its own library. So it has Keras, it has JAX, but the reality is that many people are using PyTorch, are using Hugging Face transformers, are using Olama to run the models locally. They are using BLLM to deploy the models in a server. So we're working very closely with all of these tool developers to make sure that they can use, that their respective communities can use the models easily. So for example, if the simplest way to try out Gemma without having to install anything is just to go to AJ Studio, and it's a free interface where you can play out with Gemma. But of course, the cool thing with open models is that you can run the models in your computer. And here's a very minimal code snippet for Hugging Face transformers, where you can create a pipeline, and in a pipeline you specify which is the task. In this case, generating text. You then specify the model, so Google, the Gemma 3, 12 billion parameter, and then you can pass the text, the prompt. Who are you answering pirate speak? And that's pretty much it. And again, it's the highest level abstraction of the library, but there are many other interesting things that you can do with this. So far, I've been talking only about doing inference or running the model, but where things become interesting is in actual doing training. So in the world of LLMs, you have two stages. You have pre-training. So in pre-training, you train a model with massive amounts of data. It's very expensive, usually computationally speaking. So you need lots of data, lots of money in compute, and you need expertise in the team to be able to do these models. The outcome of this stage is a next token predictor. So it's a model that has some kind of statistical understanding of the training data of the text, and it will generate the next token. But when you interact with ChatGPT or with Gemini, you are not expecting the model to predict the next token. You are having conversations, you are having a chat. And this is something that the pre-trained model doesn't do out of the box. You'll do something called post-training. So if you have heard about fine-tuning, RLHF, post-training, all of these fall like in this bucket. And here you are shaping the behavior or the personality of the model. So if you want a model to be a chat or a conversational model, this is where you do it. And here you require much less data. You can train the model on a targeted data set. And this is what really turns a next token predictor into a product. Uh, so just to go a bit deeper, why to fine tune? So the first of all is if you want to add new capabilities to the model, right? So let's say that you have a model that kind of works well in Spanish, but it's not great. So maybe you have your own data set of text in Spanish for certain uh, dialect or certain version or certain region. You can improve the capabilities of the model for that language. Or if you want the model to be able to do object detection for image inputs, you can have your own data set with just a few hundred images with the object detection labels and use this data set that you have to improve the capabilities of the model for your own use case. The second part is, well, the first two points are a bit connected, but also like changing the style, right? If you want the model to be very conversational, or if you want the model to be very concrete in the responses, this is where you do it. And then what is very common in the industry, you may have your own use case or domain. So you may be working in finance, or you may have your data set of internal use cases. So this is data that you cannot just share externally, or you may not even be able to train a model in another cloud or in another place that you don't control. And this is where open models fit very well because you can customize the models without that much data for your own use case. And there are a couple of different ways to do post-training. I will not dive too much into this because it's for a longer talk. But the most standard way is to do something called supervised fine-tuning. And here you pretty much have a data set of prompt response, let's say. And the idea is that the model should be able to predict the response based on the prompt. Uh, and standard fine-tuning should be done if any existing instruction model, so any chat model or any model that does instructions, does not work out of the box for you. And if you need to keep pushing the performance, but before just doing fine-tuning, you should just try prompting the model and see if it works out of the box. Uh, Sometimes fine-tuning a model is not that cheap because you need to iterate a bit, you need to compute, so you may also want to at least check if a larger general model will work better than a super small specific model for your own use case. And as I was saying before, if you require specific formatting, so certain chat structure, if you need the model to output code in certain format or some style decisions, uh, that's what SFT is for. Uh, there's also something called RLHF, or reinforcement learning from human feedback. And it's not one or the other. Usually this work has different stages in a longer pipeline of post-training. RLHF, the idea is that you can define some reward signals that predict which is the response that humans prefer. So for example, maybe it's knowledge related as in the example here, but maybe it's more like based on the style. As I was saying before, if you want the model to be very quick on the answers, or if you want the model to be very chatty, those are things that are incorporated in this reward signal. So maybe you don't want the model to add emojis in the responses. So if the model has some emoji in the response, you may want to have a negative signal here. But there are much more complex reward signals related to code, for example. So you may want the model to generate code, and you may want to execute the code. And if the model is the code that was generated by the model is not executable, you may want to have a negative reward signal to avoid the model generating uh, invalid code in the future. And again, there are many different tools for doing fine tuning. One of them is called TRL, which is a wrapper around the Transformers library. And they have out of the box nice recipes for RLHF, SFT. For RLHF, they have different optimization techniques with different recipes. So there are lots of resources around this. It's very experimental, empirical. There is good research behind this. But at the same time, lots of this kind of iteration work is really iterating. Uh, Many times it's just improving the data. And actually, most of the work I would say is on the data. But there's some very interesting work in post-training techniques. And what you see here in the leaderboard, this is the same one as before, what you see here in the leaderboard are the results of the post-trained model. It's not the pre-trained model benchmarks. For those, you usually have other kinds of benchmarks. Uh, Something that you may be wondering is, can you run these models? And you can do some rough napkin math, and pretty much just to load the model, you can say, okay, I multiply by 2, and that's the number of gigabytes that I would require just to load the model. So for example, for a 27 billion model, you may require 55 gigabytes, a GPU with 55 gigabytes, which you probably do not have. And here I'm putting bfloat 16, which is the precision. So if you understand like models, 27 billion means that you have 27 billion parameters or numbers. Each of those numbers are have some precision. That means how many bits you're using for every single of those 27 billion parameters. So bfloat 16 means 16 bits, but you can use fewer bits to load the model. And of course, the quality degrades because you're kind of truncating or cutting some of the bits, but this allows you to run, for example, a 27 billion parameter model in 14 gigabytes rather than 54. So this makes the models much more accessible, but you have a quality loss. So there is something called quantization-aware training. Quantization-aware training is a technique that makes the model more robust to quantization. So pretty much it is an additional post-training stage with very few samples, maybe 5,000 samples. And after that stage, you can quantize the model for a specific format while preserving the same quality as the original model. So for example, rather than require 2 gigabytes to load a 1D model, you just need 0.5. So this is the same as the previous table, but it's a bit nicer. And just to wrap up, I want to share some interesting case studies that we have seen by different institutions. So AI Singapore, they did something called Sea Lion. It's a model trained for 14 Southeast Asian languages based on Gemma 2. So they picked Gemma 2, they had their own data sets, and then they push further the capabilities of Gemma 2 for those 14 languages. And this is an open model now that anyone can go and benefit from. Here it's the of the same model. Here you can see at the top right, this is the Sea Lion model based on Gemma 2. And you can see that it's doing very well, both for English, but also for the C, so for these 14 Southeast Asian languages that they were targeting for, compared to maybe the raw model that was here. And this is just one example. There are over 70,000 models, open models in the open source ecosystem based on Gemma. Uh, and again, my goal here is not just to share about Gemma, it's more to talk about the power of making things open, making things community driven, and sharing with the ecosystem. So we have seen CoreGemma, which is for Korean conversations, to Gemmax for translation, to applications for retrieval augmented generation in Arabic and English, to generating images, to having audio as input, to even doing new research such as new preference algorithms. So it's quite exciting to see all of this huge ecosystem growing around Gemma. And we have done things such as a Kaggle competition a few months ago in which we were collaborating with the community for them to train Gemma models for their own languages. We saw over 7,000 entries. Out of this, there were some very exciting projects, even like ancient English, for example, to very specific low resource languages. And just a few weeks ago, again, this was on the 22nd of May, we released Gemma 3N, which is a model optimized for on-device. And for on-device, I mean running in a phone or IoT or in your browser. Uh, with expanded multimodal, so it has audio input, and it has a new architecture called Matformer, which allows you to extract submodels down to one to 2B actually from the main model. Don't worry if you don't understand that part, but what is exciting is that you just need 2 to 3 gigabytes of GPU to actually run this model. So again, like this can lower the barrier of entry to experimenting with these models quite a bit. And it's a very nice model. It does a bit better than the previous Gemma 3 4B model that we had. And it seems to be liked quite a bit by the community. So that was pretty much it from my side. I'm very excited to see what the community keeps building from our side. We plan to keep shipping models. And again, my goal of this talk is to share a bit which are the tools of the ecosystem and to share a bit this kind of collaborative mindset. I think the goal is not to have the whole pie, but really grow the pie. There's a huge model, like huge ecosystem of open models. Hugging Face has over 1.5 million models right now, open models right now. And I think we are all of us are pushing together the boundaries of open machine learning. So it's quite an exciting moment. Thanks.
Hey, thank you so much, Omar. Thank you for that. Um, Let me go. I mean, reminder for everybody to share their questions. Feel free to post them. We'll go through them. We have a first question from Jesus Ramos. So what he says is, so these are transforms at their core. Is it just
Yep.
through novel architectures that you are able to run them in modest CPU-based hardware like phones? Is Gemma only running inference, or is it fine-tuning the documents on the hardware it resides?
That's a fantastic question. So yes, all of the models you see in the ecosystem are transformer models at their core. Transformers are a model architecture from I don't know 6 years ago now, maybe a bit longer. So there has not been a huge architectural change in the like paradigm change in the ecosystem of architecture. So we are still using transformers. We are do optimizations like architectural decisions explicitly aimed for on device. So things that can reduce, for example, the KB cache, which is something that takes quite a bit of compute to run these models, to optimizations specific for CPU. So we do architectural decisions having in mind that we want to run these models locally in a phone. Uh, you can do fine tuning or inference with these models, but fine tuning at the moment is compute intensive. For me, one of the dreams is if we can really get fine tuning working well. I mean, in a laptop, you can do it, in a computer, you can do it, but I want to do fine tuning in my phone. And I think that will be quite interesting from a privacy perspective because what you can do next is you can fine tune with your own data with a model in your phone. Like, so let's say that you put your phone to charge in overnight, and then it keeps fine tuning with some of your data locally, but the data never goes to any server, and the weights always stay in your phone. There are some techniques like Kilora that help a bit there, but we are not still there in terms of tooling for like a Android or iOS fine tuning. Uh, I think that's where we are going to end up landing, though.
Awesome. Um, Jesus has a follow-up
Yeah.
question. How about embedding it on a Raspberry and have it offline for remote places?
Yeah, so Raspberry we have done already, Jetson Nanos as well. So IoT we have been testing actually just yesterday. There was a new library called LightRT LLM, which is a library by Google. Uh, and as part of that, they are releasing like so it's a C++ library to run LLMs in edge platforms. So that is that you can run these models in macOS, Windows, but also embedded. And they also support Linux and Android. So we do have some of the tooling for inference. Uh, and again, the smallest Gemma model right now runs with 2 GB of VRAM, but we have some exciting, and there are techniques to go even lower, but we have some interesting work with even smaller models that could enable like, even cooler applications for remote places. But the tooling is there, so you should be able to do that. Yeah, power to the people. I think is kind of what we want to do. Really enable, make the models as accessible as possible by making them well integrated with the open source ecosystem and making the models small, so you can run them in compute that is not power hungry. That means that you don't require lots of electricity or maintenance to be able to use and leverage these models.
Omar, on my side, I have a question more from the enterprise perspective.
Mhm.
So, with things moving so fast, um, what are, and companies, once they get into something, they need to train their people, commit to a model or an architecture or platform or vendor, and then train and say, okay, this is how we're going to be doing things for the next several years, right? It's difficult for enterprises to be jumping from one way to the other to the other. So, what is having that context? What are the safe decisions that can be made? Well, not safe, but at least just well, good investments that can be done in terms, I mean, how much are things changing? How much should they be like on the latest models? How much of the concepts apply from one model to the next, or one architecture to the next architecture?
Yeah.
um, what would be some recommendations for more of the enterprise audience that is getting into starting to use open models, looking at how they can fine tune them for their domain, for their specific applications?
Yeah, so my first recommendation would be have your own benchmarks. So there are many public open benchmarks and evaluations, but at the end of the day, when you pick your own model, like when you pick a model, you are picking it for your own use case. So you need to have your own internal evaluation toolkit and benchmarks to try out different models, be it open models or proprietary models through APIs, but you need to have some kind of benchmark to evaluate these models for your own use cases. The open external benchmarks are good proxies and are good signals that you should take into account, but at the end of the day, what matters here is your use case. So that's my first suggestion. The second one would be to build tooling and infrastructure in a model agnostic way. Of course, every single model has its own kind of complexities, but ideally, lots of this open source tooling allows you to quickly switch from one model to another. Uh, and my third is not maybe like an investment suggestion, but keep things simple. I think sometimes the bias is towards directly experimenting with fine-tuning models when many times the existing models out of the box work well. We have seen situations in which people try to fine-tune Llama for their own languages because they thought they could push much further the capabilities, and the result was that Llama was still like working just as well as the fine-tuned model. So this is changing a bit because 1 year ago, everyone was doing fine tuning all the time. We are seeing maybe fewer people doing fine tuning because we are seeing stronger generalist models that work well for a wide range of use cases. So always begin with the generalist model. Uh, Always begin with the smallest model, maybe, and then keep going larger if you need it, if the model is not matching your requirements. But yeah. And maybe more from the talent point of view, I think we're in a moment in which having more AI engineers is important. An AI engineer is probably not well defined anywhere, but people that understand machine learning at the point that they understand quality, they understand how models work. Maybe not all of the math behind them, but they do understand uh, high-level architectural decisions, how to fine-tune models, how to put the models in production, and they understand also like the software engineering code and engineering side of things. So if you have good machine learning skill set and good software engineer skill set, I think there are very few people that have that kind of match of skills, and I think that kind of people are really needed in the enterprise world as well.
Okay. Well, thank you
Oh,
so much for your time, Omar. I'm sorry. Or you want to say something? I cut you off. Please go ahead.
would you mind if I give one other suggestion?
Sure, please.
There are lots of hype at the moment, and I think everyone wants to use machine learning for their things. That's fantastic. I think it's important to have domain experts involved in this, right? So I mentioned MedYama before. For MedYama, the team that developed it was not us. It was a team that works with clinicians and people in hospitals and people in the healthcare industry. Uh, and I think, for example, if you want to work in machine learning for biology, that's fantastic. If you are able to have people that understand both machine learning and biology, or domain experts that work on biology, and you connect them with machine learning specialists, I think that that combination of machine learning with other disciplines, that can be extremely impactful and powerful. But you do need to involve people from other disciplines. It cannot just be done by people working in the machine learning sector in a bubble, let's say.
Definitely. Okay. Well, thank you so much, Omar. Thanks for
Thank you.
taking the time to be with us and sharing your insights on what's happening. Where can people follow you or know more about you or connect with you? I
Yeah, you
guess.
can connect with me. So I use Twitter quite a bit, so feel free to reach out to me in Twitter. Otherwise, if you don't want to use Twitter, which is understandable, you can use LinkedIn or yeah, like the normal platforms.
Okay. Well, thank you so much, Omar.
Thank
And
you.
everybody, we're coming up to the next session in about a minute. Feel free to start jumping into our next session. Thank you, Omar. Bye bye.
Thank you.